Practice a few more. So looking at our quotient rule, one thing I like to do is to figure out the derivative of the top and the derivative of the bottom, so that when I go and put it into my quotient formula, I already have those pieces figured out. So if we're looking at the derivative of 5e to the t, well, we need to think of this as a little mini product rule, the 5 and the e to the t. So the product rule tells us the first times the derivative of the second plus the second times the derivative of the first. Remember, the derivative of 5 is 0. So the derivative of 5e to the t would be 5e to the t. And then we need the derivative of 2 plus 3t squared. The derivative of 2 is 0. The derivative of 3t squared is 3 times 2 is 6t, and it would be to the first. So as we go to take our derivative, p prime is going to look like the bottom, so the original bottom right here, 2 plus 3t squared times the derivative of the top. We figured that out as 5e to the t. Bottom times the derivative of the top minus the top, which was originally 5e to the t, times the derivative of the bottom, which we figured out, that's 6t, all over the denominator squared. So 2 plus 3t to the second squared. If you look at these, there's a 5e to the t in both. So if we pull that 5e to the t to the front, so p prime equals 5e to the t, we'll be left with 2 plus 3t squared minus 6t, all over 2 plus 3t squared. Now you cannot cancel these. This right here is tied up as part of the parenthesis. It will not simplify with what's on the bottom. The only way you could have canceled it is if we could have pulled that 2 plus 3t squared to the front as its own term. Even right here, you cannot cancel it because it's not pulled to the front as its own term. It's still being multiplied and then subtracted over here, and there's no 2 plus 3t squared on this side. So you cannot cancel. So that's finished right there. Let's look at the next one. Look right here. You see how you have x? That means that the variable is x. So this right here is the only spot the variable occurs. So in this one, the a, the b, and the c are all constants. We don't know what they are. They could be 5, 7, 2. We have no idea. But we know the variable is x because right here is f of x. So that means that the only place that we see the variable is right here with this e to the x. So what is the derivative of a constant? Well, the derivative of a would be 0. What is the derivative of the bottom? The derivative of b would be 0. And then we have our c e to the x. So the derivative of the bottom would just be the c e to the x. And it's the same thing that we did right here, just like with 5e to the t. So let's find this derivative. F prime of x equals the bottom, so b plus c e to the x, times the derivative of the top, minus the top times the derivative of the bottom, all over the denominator squared. Well, it's times 0, so this whole thing goes away because it's times 0 because of that constant. So that looks like we'll be left with f prime of x equals negative ac e to the x over, and then we'll still have our denominator squared. And that'll be finished. Let's try the next one. So here, the derivative in our numerator is going to look like the derivative of t is 1. The derivative of t to the third is 3t to the second. And the derivative in our denominator, the derivative of t to the fourth is 4t to the third. And the derivative of minus 2 is 0. So that goes away. So y prime will look like the bottom, t to the fourth minus 2, times the derivative of the top minus the top times the derivative of the bottom, all over the denominator squared. So it'll look like this. If you want to try to cancel, you can do your FOIL, your double distribution. You can simplify it down. I'll let you give that a try, and I will tell you that it works out to be negative t to the 6th minus 3 t to the 4th minus 6 t to the 2nd minus 2 all over t to the 4th minus 2 squared. So that would be if you do your FOIL like this for each of them, and then you simplify to combine your like terms. So give that a try if you want, and then you'll have your y prime. Let's practice 2 more. Let's look at the product rule again. Number 7, the product rule. Here is the first. Here is the second. Now you could multiply it through. You could multiply everything by that square root of v, but it won't help you out because you'll still have a product rule right here with your 2e to the v times the square root of v. So yes, you can do that, but no, it won't really help you avoid the product rule. You're still going to have to use the product rule. So let's figure this out as we go through. I prefer to think of this as v to the 1/2. If you want to think of it that way, that's fine as well. So the product rule says you take the first, so v plus 2e to the v, times the derivative of the second. Well, the derivative of v to the 1/2 would look like you bring down your power and you subtract 1. So that will be 1/2 v to the negative 1/2. And then plus the second, well, the second was that square root of v, or v to the 1/2, times the derivative of the first. Well, let's figure that derivative out. The derivative of v is 1, and then the derivative of 2e to the v is 2e to the v. There we go. If you FOIL this through and simplify it down, which you can do, it will look like v times 1/2 v to the negative 1/2 will work out to be 1/2 v to the 1/2. And then 2e to the v times 1/2 v to the negative 1/2 will look like e to the v, whoops, times v to the negative 1/2. And then we can come to this side. V to the 1/2 times 1 is v to the 1/2. V to the 1/2 times 2e to the v would be plus 2v to the 1/2 e, oops. Let's make that look a little better. There we go. Let's see. Is there anything that we can cancel out? Well, we can't really cancel it, but we can combine our like terms right here and right here. That looks like the best we're going to be able to do. So 1/2 plus 1, that's going to give us 3/2. So 3/2 v to the 1/2. And then we have e to the v, v to the negative 1/2, and 2v to the 1/2 e to the v. If you prefer to leave it with the square root notation, you can, and that will look like 3/2 square root v plus e to the v over square root v plus 2 square root v e to the v. Either way is just fine. Look at this one. Again, we have a product rule, first and second. So y prime, the derivative is going to look like the first. So that will be r squared minus 2r. times the derivative of the second. Well, the derivative of e to the r is e to the r. Plus the second times the derivative of the first. So the derivative of r squared minus 2r will be 2r minus 2. I have that e to the r in common again. So if I pull that to the front, we're left with r squared minus 2r plus 2r minus 2. So this one is simplified just a little bit more with these canceling. So we'll look at y prime equals e to the r times r squared minus 2. If you wanted to distribute your e to the r, you could. You don't have to, but you could. Either way would be fine.